Hello and welcome to Module 4 for ED 584. And let's go ahead and get started. And here I have Module 4. Again, you can get to Module 4 by entering through the home page that comes up. Or you can come through the instruction page from the previous module. And we will get this link ready before we make this available. So apologize for that not being ready to go. So let's go back to the home and then to Module 4. And a little bit about the photos. As I mentioned in my introduction, I enjoy reading about Abraham Lincoln, kind of a mini history buff with Lincoln. And I'm from Illinois. Lincoln's from Illinois. There's documentation that when he rode the circuit as a trial lawyer in Illinois, that there was a case involving the farmer who owned our ground at the time and a farmer who owned the ground next on the farm next, and that Lincoln was a part of that. We don't have the we don't know for certain that Lincoln came out to the farm, but there is some evidence that he did. But I can't confirm that. So the photos, the first one, the top one is of the Lincoln Memorial photo I took, and then back when I was in Illinois, this was in I think 2012, and took pictures at Lincoln's tomb in Springfield, Illinois. So let's go ahead, let's get going. Module 4 is going to serve as a transition from descriptive statistics such as probability, normal distributions, and sample distributions to that of hypothesis testing and inferential statistical procedures. Inferential procedures begin with the researcher articulating a hypothesis, which can be stated in the null or alternative forms. And this articulation of a hypothesis is about a population, and then testing that hypothesis to see if it appears to be correct based on an interpretation of statistical analysis. The goal of inferential statistics is to infer findings from a sample to that of a population. In review, a critical aspect that allows for this is that the sample has been selected through some form of random selection process. The extent to which we can correctly infer the sample findings to that of the population is called external validity. For this module, we are particularly concerned with hypothesis testing of means. More specifically, we will examine the z-test procedure, which forms the basic foundation of many other procedures. The purpose of the z-test procedure is to test hypotheses concerning a single population with a known variance. Because the z-test requires information about the population that we often do not have, and that is such as variance, we also begin to explore other procedures that are more commonly used. Specifically, we begin looking at one form of a t-test, that being a one independent sample t-test. This t-test procedure serves the same purpose as the z-test, but does not require us to know the population variance. We use the one independent sample t-test to compare our sample data to that of the known population parameter, such as the mean in this case. We are interested to know that the population from which our sample is taken has the same mean value as that of the known population parameter. For a one independent samples t-test, the purported population mean is stated as either being tested to see if in fact the purported value is valid, or if a sample from another population is the same. Either way, the results indicates whether the sample mean is representative of the purported population mean. Two independent samples t-tests are also studied. This form of the t-test is used to investigate whether or not a statistical difference exists between groups. Assumptions associated with this test require that the sample was randomly selected, that the population from which the sample is drawn is normally distributed, and that the two samples are independent from each other. Like with other hypotheses testing, the null hypothesis is tested through the use of the t-test procedure. Finding a statistically significant difference leads us to follow procedures. Effect size is studied and calculated as a statistic that represents the size of the difference of a statistically significant finding. Power is then examined. Power represents the likelihood that we will reject the null hypothesis when in fact the null hypothesis is false. It is interesting to reflect on the fact that a statistically significant finding may not have any practical implications if the difference found is minimal. Thus, the importance of us also examining effect size. One of the issues can be that with large sample sizes, very small differences between means may show a statistical difference that does not represent any real practical difference. That is where effect size comes into play, and many research journals require researchers to report the effect size of their findings within published research manuscripts. Okay, so here are the objectives, and I'll let you go through those. And then the assignments for the readings from the Statistics for the Behavioral Sciences, Chapter 8 on hypothesis testing. We've included the supporting PowerPoint from the author. And then I've also included 2 good videos on hypothesis testing and then on power and effect size. And just like the previous modules, just go ahead and click. And then you'll come in and your videos will start. Okay. Then there will be Chapter 9, testing means, 1 sample and 2 independent samples t-test, supporting PowerPoint from the author, then YouTube video on 1 sample t-test, and then on 2 independent samples t-test. And then from how to use SPSS, it's Chapter 6, sections 1 and 2, hypothesis testing and single sample t-test. And for the other assignments here, click on here. This will take you to the reflective commentary to post your commentary. And then here at the end are things to consider for the next module. As always, do not hesitate to let me know if you have any questions. Take care.